Then moving average, the moving average is that we predict our, for example, sales based on the error, based on the error. Error maksud di sini lah perbezaan di antara, so your basically error is a big perbezaan di antara the real value and your perbezaan di antara y and your y hat. Y is the real value, real time value, and this is a estimated time value. Estimated time value dan real time value ini bukan maksudnya kita menganggar masa, kita menganggar sesuatu nilai berdasarkan masa lah, sebab in the time series we are talking about timed. Time can be day, week, months, year, minutes, second, and so on and so forth. That is time. So your time and the value. For example, share price. Share price, harga saham. So untuk moving average method, we are dealing with the real value. For example, share price, the real share price value y, and the estimated price value y hat. And this difference is your error term. So kalau ini yt and here is yt, these are your epsilon t. Setengah buku dia menulis sebagai y, setengah buku dia menulis sebagai x. Setengah menggunakan x, kadang-kadang ada buku menggunakan x, ada setengah-setengah menggunakan y. Ada setengah-setengah menggunakan z model, zt, depending kepada, bergantung kepada penulis pakaian lah. So this variable tak semestinya y ataupun tak semestinya x. The name of the variable can be a, b, c sampailah whatever penulis tu nak gunakan lah. So untuk case ni, case yang pertama ni, so dia menggunakan sebagai y. So moving average kita ada M1, MA1, MA2 up to MQ or MAQ. Q ni dipanggil 1, 2, 3 sampai Q ni 1, 2 up to Q. This thing is known as lag. Lag. Kalau MA1 seperti yang saya katakan dulu, kalau kita ada data YT, MA1 maknanya kita regress YT dengan epsilon T minus 1. Epsilon T minus 1. Kita regresskan ataupun kita dapatkan, kita gunakan least squares method. Untuk regress. Maknanya regress ni kita dapatkan persamaan ataupun kita halusi ataupun kita mencari hubungan di antara YT dengan epsilon T minus 1. That is for MA1. Kalau MA2, maknanya kita regresskan YT bersamaan dengan epsilon T minus 1 and epsilon T minus 2. Maksudnya kita akan mendapat multiple regression. Kalau MA3, kita regresskan YT bersama dengan epsilon T minus 1, epsilon T minus 2, and epsilon T minus 3. Kalau MAQ, kita regreskan di antara YT dengan epsilon T minus 1, epsilon T minus 2, epsilon T minus 3, up to epsilon T minus Q. That is a MAQ. Kalau awak ingat konsep regression, kalau awak ingat konsep regression, saya pergi balik kepada konsep regression. So for the concept of regression, kalau kita ada Y and X, kita gunakan Y and X. Okay. So Y and X. Tapi kalau dalam MA1, kita gunakan Y dengan epsilon T minus 1. This is your dependent. And here is your independent. Right or not? Dependent variable. So kalau konsep regression, Y dengan X lah, so Y is equal to A plus by BX plus by epsilon. That is a concept of regression. Sama juga dengan MA1. So MA1, digunakan konsep sama. YT is equal to, instead of A, we use mu. Plus by theta 1 epsilon T minus 1. Because of your X here is epsilon T minus 1 plus by epsilon T. That is a MA1. So this is a MA1. Begitu juga kalau MA2, this is a linear regression. Linear regression. Kalau kita ada MA2, it becomes multiple regression. So YT is equal to mu plus by theta 1 epsilon T minus 1 plus by epsilon T minus 2 plus by epsilon T. Ini dah menjadi this become epsilon T. Epsilon T. This become multiple regression. Dan untuk multiple regression, dia agak sukar sikit lah untuk kita mengirakan dia punya ni. Kita nak kita perlu ada satu software ataupun kita boleh gunakan SPSS untuk mencari, mengira untuk multiple regression. You just imagine this is a MA2. Kalau MA3 maknanya you ada tiga error. Epsilon T minus 3 and so on so forth lah. Kalau MAQ maknanya you ada MAQ sampai Q lah. So multiple regression. So hari ini saya akan tunjukkan MA1 and MA2 sajalah. So to prove MA1 and MA2. Dan for the general formula for MQ. Okay. Now, yang pertamanya kita nak provekan dia punya mean. Dia punya mean for MA1. Okay. Now, let's say I have MA1. MA1 MA1. So MA1 is equal to YT ataupun yang penulis ni gunakan YI pula kita gunakan YI lah. Tak apa, YI is equal to mu plus by theta 1 epsilon I minus 1 instead of T kita gunakan epsilon I plus by epsilon I. By definition, okay, dia punya error epsilon error is normally distributed with mean zero and variance sigma squared. That is epsilon. The epsilon is normally distributed. The residual is normally distributed with mean zero and variance sigma squared. Okay. Epsilon I is normally distributed with mean. These are definition by definition. So kita nak prove kan apakah nilai ni? Kita nak tunjukkan this one become mu. Okay. So untuk membuktikan ini adalah bersamaan dengan mu, kita untuk proof kita nak carikan, we want to prove mean of, ini dia prove mean of moving average Q. He want to prove mean of MAQ is equal to mu. I want to prove mean MA1 is also equal to mu. So mean MA1 is expected of, kalau mean is expected of YI. Expected of YI, kalau MA1 is expected of the whole thing here. Mu plus by theta 1 epsilon I minus 1 plus by epsilon I. Kita ambil yang atas ni. So this can be written as expected of mu plus by theta 1 expected of E I minus 1 plus by expected of EI. Now mu is considered as constant. Expected of a constant is a constant. So it become mu plus by theta 1 expected of EI. Maknanya the mean of EI is, kalau by division, mean of EI or EI minus 1 or EI minus 2 is equal to 0. So expected or mean of EI minus 1 is equal to 0 plus by expected of EI also equal to 0. So 0 plus by 0 is equal to 0 and plus by mu is equal to mu. Sebab itu kita dapat the mean for MA1 is equal to mu. Okay. Mean for MA1 is equal to mu. Begitu juga kalau kita nak provekan this one. Let's say I have mean of Q, MAQ. So MAQ, the function is YI is equal to mu plus by theta 1 epsilon E minus 1 plus by theta 2 epsilon I minus 2 plus by dot plus by theta Q epsilon I minus Q. So kalau kita letak E di sini, maknanya expectation. Untuk mencari mean, kita letakkan expectation YI equal to expectation of the whole thing here, expectation of mu plus by theta 1 epsilon I minus 1 plus by theta 2 epsilon I minus 2 plus by dot plus by theta q epsilon I minus q. So kalau you open the bracket here, right? So this become expected of mu is expected of mu E mu plus by theta 1 expected of E I minus 1 plus by theta 2 expected of E I minus 2 and plus by up to plus by theta q expected E I minus q. So we know that the expectation of epsilon I, whatever I minus 1, I minus 2, all this thing is equal to 0. This part is equal to 0, this part is equal to 0, and this part is equal to 0. So the thing here is that expectation of mu, expectation of a constant is mu. So become plus by 0, plus by 0, plus by dot, plus by 0. So that's why the answer is equal to mu. Okay. Ini cara untuk kita proofkan expectation of MAQ, the mean of MAQ is equal to mu. Okay. Now, the next part is I want to show that the MAQ is equal to MA1 is so I want to prove MA1 is equal to sigma square. Sigma square. MA1 is equal to sigma square T1, sigma square theta 1 square, sigma square theta 1 square. Okay. Now, so I want to prove that for MA1, so your variance for MA1, the function is yi equal to mu plus by the theta 1 expectation of I minus 1 plus by epsilon I. Okay. So the variance of this one is equal to variance of yi. So kita letakkan so ini kita nak cari variance of yi equal to variance of mu plus by theta 1 expectation of epsilon I minus 1 plus by epsilon I. So this will give me a value of variance of mu plus by variance of theta 1 epsilon I minus 1 plus by variance of epsilon I. Now, variance of a constant is a 0. Variance of constant is equal to 0. So variance of constant is equal to 0. So mu is a constant. Variance of constant equal to 0. Plus by variance of theta 1 epsilon I minus 1, you can put as a theta 1 square variance of epsilon I minus 1 plus by variance of epsilon I. Now this will give me the answer of 0 plus by theta 1 square. Variance of epsilon I, by definition, epsilon I is normally distributed with mean of 0 and variance of sigma square. So variance of epsilon I minus 1 is sigma square. So sigma square plus by variance of epsilon I is also sigma square. So sebab itu kita dapat theta 1 square sigma square plus by sigma square. So ini akan menjadi sigma square multiply by theta 1 square plus by 1. Okay. This is a variance of MP1. Variance of MP1. Kalau kita ada MEQ, so if we have MEQ, now if we have MEQ, the variance of MEQ kita boleh gunakan cara begini. Kita akan susunkan YI equal to mu plus by theta 1 epsilon I minus 1 plus by theta 2 epsilon I minus 2 plus by up to theta Q epsilon I minus by Q. So the variance of YI, you just put as a variance of YI equal to variance of mu plus by theta 1 epsilon I minus 1 plus by theta 2 epsilon I minus 2 plus by dot plus by epsilon theta Q epsilon I minus Q. So you can put this way. So if you open the bracket here, you will have variance of mu plus by theta 1 square, variance of epsilon I minus 1 plus by theta 2 square, variance of epsilon I minus 2 plus by dot plus by theta Q square, variance of EI minus by Q. So by definition, variance of mu, the variance of a constant is equal to 0. This is equal to 0. So it becomes 0 plus by theta 1 square. Variance of epsilon I minus 1 is sigma square plus by theta 2 square. Variance of epsilon I minus 2 also equal to sigma square plus by dot theta Q square. Variance of epsilon I minus Q is sigma square. So if you simplify this form or this equation, you will have sigma square theta 1 square plus by theta 2 square plus by theta 3 and so on and so forth plus by kita ada satu lagi, kita ada tinggal ni. Kita campur dengan, the last one is saya campurkan dengan variance of epsilon I. So plus by sigma theta 1 theta Q square plus by 1. Okay. So ini akan menghasilkan, this is the final answer, plus by 1. So the same as this one. This one plus by variance of epsilon I is sigma square. Ini kita cuba kita proofkan apa dikatakan sebagai the variance of y. Okay, now then we want to prove for the covariance, the covariance ataupun the autocorrelation function. So the autocorrelation function given that the autocorrelation function for ME1 autocorrelation, the concept of autocorrelation is the same as the correlation. Okay. So kalau awak ingat lagi korelasi dalam bahasa bawa belajar basic statistik, correlation maksudnya hubungan di antara X dan Y. Hubungan di antara the association or the correlation or the relationship between X and Y or Y and X, then the association or the relationship is known as the correlation. So basically, the formula for correlation for X and Y. Okay. Let's say I want to show you the formula for correlation of X and Y. See, the formula for correlation of X and Y. Let's say kita ada X and Y. For this case kita gunakan Y dengan epsilon kan. Tapi saya akan tunjukkan macam mana Y dan X dulu. Y dengan X maksudnya korelasi dia lah Y dan X. So you still remember R is equal to N sigma XY minus by sigma X sigma Y over square root of N sigma X square minus by sigma X square multiplied by N sigma Y square minus by sigma Y square. This is the correlation. In other words, this part, the numerator here is known as a covariance. And the denominator here is this is the standard deviation. Standard deviation for x and the standard deviation for y. Standard deviation for y. Okay. So in other words, covariance is the R ataupun correlation. R is equal to correlation equal to the covariance sigma xy over the standard deviation of x and standard deviation of y. This is a concept of correlation. A concept of correlation. Kalau kita lihat formulanya beginilah untuk x and y. And for this case, okay, dalam time series kita tak sebut correlation, kita sebut autocorrelation. Autocorrelation is in term of time series, autocorrelation. Kalau dalam application biasa kita sebut correlation, so in time series the correlation is known as autocorrelation. Then function, and because of we have the equation, then nama dia dah akan menjadi function. Okay. So I want to prove you that the autocorrelation for MA1, row 1, so MA1 sebenarnya autocorrelation dalam istilah biasa kita gunakan R. Correlation kita gunakan R. Tapi since of MA1 kita gunakan istilah row ataupun R1. Jadi row 1 because of MA1. Kalau MA2 kita ada row 1 and row 2. That is autocorrelation. So for this case, for the autocorrelation for MA1 is given as row 1 is equal to theta 1 over 1 plus by theta 1 square. That is autocorrelation. And by definition, the autocorrelation is equal to, kalau kita ada Y1, okay, kita ada YI, so MA1 is equal to MA1 is equal YI dengan epsilon I minus 1. So autocorrelation of this function you will have is a covariance of autocorrelation is a covariance of YI and YI minus 1. Maknanya autocorrelation is kalau kita ada you want to find the autocorrelation, maksudnya kita carikan bukannya YI dengan epsilon I minus 1, I want to find the autocorrelation between YI and YI minus 1. This is MA1 punya autocorrelation. Maknanya autocorrelation YI dengan YI minus 1. Okay? The autocorrelation of YI and YI minus 1. So for MA1. And the autocorrelation is YI and YI minus 1 and YI minus 2. Okay. So dia punya formula is more complicated lah. So kalau kita nak lihat autocorrelation between YI and YI minus 1, maksudnya kita akan mencari the covariance of YI and YI minus 1. Okay, macam formula ni, formula asal ni lah. The correlation is ataupun autocorrelation is the variance of covariance sigma xy. Maknanya kita akan mencari sigma YI and YI minus 1 over the standard deviation of yi and standard deviation of yi minus 1. Yi minus 1. This is the what I call the autocorrelation function, okay? Or rho 1. This is rho 1. Kita nak cari benda ni, this part, and this part. So penulis dia menggunakan, dia terus menggunakan, dia tidak mencari satu, dia mencari I minus by H terus. Yi dengan yi minus H. Okay. So cara proofnya lah, kita terus mencari covariance of, kita comparekan, kita mencari covariance of yi and yi minus H. So covariance of yi and yi minus H. So covariance maknanya the autocorrelation function rho here. Rho here is rho H. Rho H. Dia terus cari rho H. Rho H. Here rho H. So rho H, but covariance of yi, covariance of yi and yi minus H over variance of the standard deviation of yi and standard deviation of yi minus H. This is a rho H. Okay. So the first part, kita cari covariance. Covariance. Okay, covariance. Ini the first part. The second part barulah kita cari dia punya variance. Okay? Kita cari dia punya variance. Second part baru kita cari dia punya standard deviation. Standard deviation. This is standard deviation. Okay. Now, saya carikan dia punya covariance. Okay. By definition, no, by definition, covariance of yi and yi minus H is, kalau anda nak cari covariance, maksudnya ialah anda kena cari expectation. Covariance of yi minus yi H is an expectation of yi and yi minus H. Okay, yi minus mu multiply. Kalau kita cari covariance of x and y, the y and x, dia akan jadi apa? Expectation of y minus mu multiply by x minus mu. Ini dalam kebarangkalian kita belajar. That is how we find the covariance. Yang saya ajar dulu, mungkin anda ingat, ataupun bukan saya ajar, orang ajar. So covariance is the expectation of y minus mu multiply by x minus mu untuk yx. Kalau yi dengan yi minus h, you just tukar yi minus mu multiply by yih minus mu. Okay. This is the covariance. Okay, fungsi untuk yi is equal to what? Yi is equal to expectation mu plus by theta 1 epsilon I minus 1 and plus by epsilon I. Okay. Ini untuk MA1 So we just put here, instead of yi, you just change to mu campur theta 1 epsilon I minus 1 plus by epsilon I minus by mu. Kalau awak tukar kat sini, ni, this is actually yi. So because of we have the mu and minus by mu can be cancelled off. That's why balance here is theta 1 epsilon I minus 1, theta 1 epsilon I minus 1 and epsilon I. Begitu juga dengan yi minus h. So for MA1, yi minus h is for MA1 is mu plus by theta 1 epsilon I minus 1 minus h, okay, minus h multiply by plus by epsilon I minus by h. I minus by 1, sorry, I minus by 1. Okay. So if you simplify this thing, you will have epsilon I minus by, okay. Now YIH, okay, kalau kita refer kepada YI is equal to mu plus by theta 1 epsilon I minus 1 and epsilon I minus by epsilon I. Okay. Instead of I, you change to yi minus h. yi minus h, you will have mu masih tak tukar plus by theta 1 tak tukar epsilon I minus 1 become I minus h, epsilon I minus h minus 1 plus by epsilon I here become epsilon I minus by h. Okay. So this will give me the value of, so this is this part. So kalau kita simplifikan this one, kita masukkan dalam fungsi this part, we add into this function, this one. So dia punya initial function ni adalah asalnya lah yi minus h minus mu. Kalau kita substitute this part dalam this function, we'll have yi minus h is a mu plus by theta 1 epsilon I minus h minus 1, okay, plus by epsilon I minus h minus by mu. So mu and mu can be cancelled off. Sebab itu kita hanya tinggal di sini theta 1 epsilon I minus h, this part, and epsilon I minus by h. Okay. No, no, selepas awak dapat yang ni, so you kembangkan ni, you expand this one. So epsilon I minus epsilon I multiplied by epsilon I minus by h is equal to epsilon I minus h, this part. Then epsilon I and theta 1 I minus 1, h is epsilon I, theta 1 epsilon I minus by h, this one, this part. Then the next part is theta 1 epsilon I minus 1 and epsilon I minus h is theta 1 epsilon I minus 1 epsilon I minus h is this one. This one and multiply this one is you have this one. The last one is theta 1 epsilon I minus 1 and theta 1 epsilon I minus h minus 1 is theta 1 square. Theta 1 multiplied by theta 1 is theta 1 square. Epsilon I minus 1 epsilon I minus 1 h minus 1. This part. Okay. This is your covariance. Okay. So, bila H bersamaan dengan 1, katakan kita nak cari ME1. Tadi kita put general H, I minus H. Sekarang kita letakkan ME1. ME1 maknanya I minus 1. Okay, I minus 1. So, maknanya we will try to find the correlation between IY and YI minus 1. Tetapi kita in general formula we put I minus H. So when H is equal to 1, maknanya ME1 lah. So the covariance for ME1 is equal to, so kalau you letak 1, maknanya expectation of I minus 1 I minus 1, expectation I minus 1, expectation of I minus 1 minus 1 is 0, expectation of I minus. So, kalau covariance of I minus H is equal to expectation of, so you will have, you put here, I is equal to 1, so just when H is equal to 1, I will have here expectation of epsilon I minus 1 plus by theta 1 expectation of epsilon I minus 1 epsilon I minus 1 plus by theta 1 expectation of epsilon I and epsilon I minus by 2 plus by theta 1 square expectation of epsilon I minus 1 epsilon I minus 2. Kalau epsilon I and epsilon I minus 2, this becomes 0. And this thing becomes 0. And epsilon I and epsilon I minus 1, this one becomes sigma. This also becomes 0. And epsilon I minus by epsilon I minus 1 and epsilon I minus 1 is become sigma square. This is by definition. Expectation of epsilon I and epsilon I minus 1 is equal to 0. Expectation of epsilon I and epsilon I minus 2 is equal to 0. Expectation of epsilon I minus 1 and epsilon I minus 2 is equal to 0. Dia kena sama. Sama baru dia jadi sigma square. Ataupun expectation of epsilon I and epsilon I is equal to sigma square. Tetapi kalau lain kaki, dia punya time frame yang lain, dia akan jadi kosong. So epsilon I minus 1, epsilon I minus 1 equal to sigma square. So the thing here become, the final answer here becomes theta 1 sigma square. That is for covariant I minus by 1. Jika H is greater than 1, other than that, the covariance is equal to 0. Dia mesti bersamaan dengan 1. Kalau selain daripada ini, dia bersamaan dengan kosong. Covariance bersamaan kosong. Okay. Dia mesti 1 saja. Lebih besar dari 1, dia mesti menjadi kosong. Okay. So, sebab itu dapat covariance of I and I minus H is equal to theta 1 sigma square. So, maksudnya, tadi kita dapat, for H is equal to 1, by property 2, where is property 2? Mana property 2? Okay. Rho ataupun autocorrelation function, rho is equal to the covariance of yi and yi minus 1. Yi minus 1. This is a covariance of yi and yi minus 1 when, because of H is equal to 1. Okay. It becomes theta 1 sigma square over the standard deviation for I and standard deviation of I minus by 1. Standard deviation for the standard deviation of sigma I and sigma I minus by 1. Now, by definition, if you want to find the covariance of the variance of yi and yi minus 1 adalah sama. Okay? Variance of yi and variance of yi minus 1 ini adalah sama. Sebab itu kat sini standard deviation is because of this formula is a covariance of yi and yi minus 1 divided by the variance, the standard deviation or square root of variance. The standard deviation is square root of variance yi, and the standard deviation of yi minus 1 is a square root of variance of yi minus 1. Okay. Now, covariance tadi kita dapat theta 1 sigma square, theta 1 sigma square over, now variance of yi and variance of yi minus 1 adalah benda yang sama. So, maksudnya kita akan dapat square root of variance of yi multiplied by square root of variance of yi, sebab dia adalah benda yang sama. Nilainya sama, approximately the same. So in other words, kalau you multiply this thing, you will have theta 1 sigma square over, you multiply by variance of I and square root of variance of I and variance, it become variance of yi. And by definition, variance of yi is, kita akan dapat daripada atas tadi, variance of yi is this one. Is a variance of y, sigma square 1 plus by theta 1 square plus by theta 2 q square. So this will give me the answer of variance of yi is equal to theta 1 square, theta 1 sigma square over variance of y1. Y1 is, variance of yi. Variance of yi is sigma square plus by, ataupun untuk ME1 variance of yi lah. Untuk ME1 variance of yi dia adalah theta. sigma square 1 plus by theta 1 square. This is a variance for yi for MA1. So in other words, you can cancel out this part. This is theta 1. Okay? This punya theta 1. Also theta 1. So in other words, you can cancel out this one. Sigma square and sigma square you can cancel off. Then the balance here become, the final answer here is theta 1 over 1 plus by theta 1 square. Ini cara kita nak prove the autocorrelation function or rho1 is equal to theta 1 over 1 plus by theta 1 square. Selebihnya, bila H is greater, rho1 bersamaan dengan kosong. Kalau H lebih besar daripada 1, rho1 sama dengan kosong. So, this is how we prove your auto ataupun correlation is equal to theta 1 plus by theta 1 square. Kalau contohlah, katakan awak ada you punya MA1 function. Let's say you have MA1 function. Given that MA1 function yi is equal to, let's say 2 plus by 0.3 epsilon I minus 1 plus by epsilon I. So in other words, this one is theta 1. Fair enough. So from here, we can get our autocorrelation function as a P1. So your correlation ataupun autocorrelation is equal to P1 is equal to, your theta 1 is 0.3 over 1 plus by 0.3 square. Awak tak payahlah calculate correlation lagi. So you from the equation here, you can just pick up nilai theta 1 is 0.3. You just substitute here to get the correlation ataupun to get the autocorrelation by using this formula. Okay? So I just prove the formula here how you get rho1 by applying the concept of variance and covariance. Okay, now the second part is I want to prove for the MA2. So panjang lah nak prove ni, nak provekan MA2 ni. Yang pertama lah kita nak prove MA2 ni agak panjang, tapi kita rehat kejap. Okay. Saya tak berbaloi lah saya nak prove MA2 ni, dia panjang sangat di sini. Takut awak confused. Okay. So basically the MA2, for MA2 you have two covariant, two autocorrelation function. One is for you have theta 1 plus theta 1. Okay, now for the autocorrelation function for MA2 is equal to this one. P2 is equal to theta 1, theta 2 over 1 plus by theta 1 square plus by theta 2 square. So that is the autocorrelation function for MA2 process. So in other words, for the autocorrelation in MA2 process, you need to find theta 1, you need to have theta 1, and you need to have theta 2. Then you just substitute into this function, you'll get the autocorrelation function for MA2. Ini adalah proofnya. Then the last one, the autocorrelation for MAQ. MAQ is equal to rho H is equal to theta H multiplied by J1 to Q minus H. Okay. Q minus H theta J plus H over 1 plus by J equal to 1 to Q theta J square. This is the PH, rho H. Okay, rho H. Tak apalah, kita go for so basically we know the autocorrelation function for MA1 and MA2. Now proof ni kita stop dulu. Jadi kita akan balik kepada proof dia. Kita pergi kepada this one. Ya, Okey, kita ambil rehat selama 5 minit. Okey, kejap lagi saya akan tunjukkan.
Nampak, Doktor.
Okey, now untuk yang ini dia gunakan konsep saya ambil nota daripada sumber yang lain. So dia tidak menggunakan Y, dia gunakan X. Seperti yang saya katakan tadi. Kalau kita boleh gunakan apa-apalah, sama ada kita nak gunakan X ke Y ke ataupun Z ke dan sebagainya. Untuk this case digunakan instead of Y digunakan X, instead of epsilon digunakan W. Kita gunakan XT tak ada nak. Wait, saya downloadkan ini dulu. Saya print. Okay. Okay, now instead of gunakan Y, this guy digunakan T dan digunakan X. Jadi kita gunakan Y kan, YI. Kita gunakan YI bersama dengan mu campur dengan epsilon I plus by theta 1 epsilon I minus 1. But this guy digunakan XT. Tambahlah XT. The first order is XT is equal to mu plus by epsilon change to WT plus by theta 1 WT minus 1. Sama lah. Instead of W, instead of E, this guy gunakan W. This is first order. Kalau kita nak tuliskan dalam bentuk yang kita tulis tadi lah, this is the same as this one. The second order is leg 2 ataupun MA2. Second order is the same as YI. Kalau kita dalam bentuk tadi, YI bersama dengan mu plus by epsilon I plus by theta 1 epsilon I minus 1 plus by theta 2 epsilon I minus by 2. This guy menggunakan XT mu plus by WT is epsilon T plus epsilon I theta 1 epsilon I minus 1 instead of epsilon I minus 1 digunakan WT minus 1 and so on so forth. Ini up to MAQ. Okay. Now, expectation of X ini dia punya kalau kita kata tadi dia punya untuk MA1 seperti yang saya tunjukkan tadi lah, expectation of YT is equal to mu, variance of YT is equal to sigma, variance of YI, kalau kita tulis dalam bentuk tadi lah, variance of YI is equal to sigma square I 1 minus by theta square 1. And the autocorrelation function or the correlation is equal to rho 1 is equal to theta 1 over 1 plus theta 1 squared. For kalau pH is equal to kosong, P2 is equal to kosong, P rho 3 is equal to kosong. Jika H is greater equal than 0. Jadi maknanya kalau untuk MA1, your row 2, row 3 semua sama dengan kosong. Okay. So, saya ambil satu contoh. Contohnya, katakan kita ada satu function yi ataupun xt, MA1, this is talking about MA1. yi equal to 10 plus by epsilon I plus by 0.7 epsilon I minus by 1, where EI is normally distributed, identically and normally distributed with mean 0 and variance 1. Mean 0 and variance 1. Okay. So from here, we know that kalau kita compare dengan our initial function here, compare dengan function MA1, this is MA1, yi is equal to 10 mu plus by epsilon I plus by 0.7 epsilon I minus 1. Which means your theta 1 here is equal to 0.7. Theta 1 is equal to 0.7. So from here, we can estimate our autocorrelation. So your autocorrelation, you just apply the formula here. Row 1, because of row 2 and above is equal to 0. Row 1 is equal to theta 1 0.7 over 1 plus by theta 1 square, 0.7 square. These are your row 1 is equal to 0.4698. This is 0. Now, if you plot the ACF function here for MA1, you will have this type of graph, this type of graph. So awak akan dapat, awak plot kan, so lag, the x-axis here is lag, ataupun h to lag, and here is your row. So row 1 or lag 1 or row 1, this is equal to, let's say here is 0.5, and the value there is 0.4698, is around here, which is like this, macam bar chart. Kalau row 2, dia sama kosong. Row 3 bersama kosong and so on so forth. So kita ada satu palang saja di sini. Now, kalau you run, you gunakan pada software, you plotkan ACF, autocorrelation function, dan tiba-tiba awak nampak satu palang je naik di sini. Satu palang saja dekat row 1. Makanya ini merupakan fungsi ataupun model MA1. Model MA1. Kalau kan ditadikan, you plot ACF function menggunakan komputer, awak dapatkan dua palang sebenarnya. Dekat lag 1 and lag 2, ini dua palang. Itu palang, ini satu palang. The rest is kosong. This is refer to MA2. Katakan kalau awak plot lagi, awak akan dapat, katakan contohnya aku jumpa 3 palang. Dekat 3 ni ada satu lagi palang. So these are MA3 and so on. So from ACF function here or ACF graph here, you boleh kenal pasti apakah model yang perlu digunakan. And for this case, the model is MA1. Okay? MA1. Sebab bila kita plot, kita ada satu palang saja. Okay? So to estimate row 1 here, we just apply the formula. So first of all, you have to pick up what is theta 1. So your theta 1 is 0.7. So theta 1 is 0.7. Then just substitute to find the autocorrelation. Just substitute theta 1 into this function. So the function just now is theta 1 over 1 plus by theta 1 square. So you substitute, you will have dia punya autocorrelation is 0.4698. The rest is equal to 0. That is an MA1. Okay, let's say you have MA2. MA2. MA2 function is like this. So penulis ni menggunakan xt equal to mu plus by theta 1 wt minus 1 plus by theta 2 wt minus 2 plus by wt. Wt is referred to our error ataupun epsilon. So kita tulis pula begini, yi equal to mu plus by theta 1 plus by epsilon I minus 1 plus by theta 2 epsilon I minus 2 plus by epsilon I. Ini cara kita tulis. Boleh awak boleh tulis cara begini ataupun tak cara yang kedua. So, given that untuk MA2, then the mean for YT is equal to mu and variance is equal to sigma square I 1 plus theta 1 square plus by theta 2 square. Ini saya dah buktikan tadi. Now, for theta MA2, your rho 3 is equal to 0. Kita ada dua saja, rho 1 and rho 2. Rho 3 is equal to 0, rho 4 equal to 0, up to rho q all equal to 0. So to find rho 1 ataupun autocorrelation for 1 is equal to theta 1 plus by theta 1 theta 2 over 1 plus theta 2 square plus by theta 1 square plus by theta 2 square. That is rho 1. Kita ada dua rho. So MA2 kita ada dua rho. MA1 kita ada satu rho. Ini dipanggil rho, RHO. Rho is referred to RHO. Rho is referred to autocorrelation. So MA2 kita ada dua rho. MA3 kita ada tiga rho. MA1 kita ada satu rho. Okay. Rho 2 is theta 2 over 1 plus theta 1 square plus by theta 2 square. Provided H is less than 3 ataupun jika lebih dari itu makanya dia adalah kosong. Okay. Kita ambil contoh je. So katakan fungsi MA2 kita diberi yi equal to 10 plus by epsilon I plus by 0.5 epsilon I minus 1 plus by 0.3 epsilon I minus by 2. This is MA2. Dia tak boleh kepada 3 Dan epsilon I adalah bertaburan secara normal dengan mean kosong, dan variance bersamaan dengan 1. So from here you can pick up your theta 1 is equal to 0.5 and theta 2 is equal to 0.3. Okay? Because of this refer to theta 2 because of I minus 2. Okay? Then from here you can substitute the formula here into this function. So bila you substitute into this function, rho 1 is equal to 0.5 multiplied by, because of theta 1 is 0.5, plus by 0.5 multiplied by theta 2 is 0.3. Then over 1 plus 0.5 square, because of theta 1 is 0.5, plus by 0.3 square. So the final answer here is 0.4851 for rho 1. And for rho 2, theta 1 is 0.3, theta 2 is 0.3 over 1 plus by theta 1, 0.1 square, plus by theta 2 square, 0.2 square. And the final answer is 0.2239. Okay, now, if you plot the graph here, you will have against legs. These are legs, number legs 10. So this is your row. So you have only row 1 and row 2, row 1 and row 2. The rest is equal to kosong. So kalau you plot sini, katakan awak tak tahu function lagi, you tak tahu function, tiba-tiba you plot, you jumpa bentuk begini, makanya di sinilah MA, MA2. Sebab dia ada dua palang. Dua palang di sini refer to MA2. Okay, boleh? So saya sentuh tentang MA2 sajalah. MA2. Untuk MA3 dia lebih complicated lah, formulanya lebih complicated. So kita berhenti sampai MA2 sajalah. MA2. Ini adalah cara untuk kita mengenal pasti. So bagaimanakah cara kita nak mengenal pasti model-model yang kita nak buat? Kita ada dua cara. Satu ialah kita gunakan how we want to determine a model. How we want to determine a model. So the model can be determined using saya ada okay, nampak tak ni? Nampak
Nampak.
Nampak.
Tak nampak? Okey, saya copy di sini. Kalau tak nampak, saya copy. Nampak tak?
Nampak.
Okay, now ini cara kita nak menentukan model-model kita. So, kalau kita nak tentukan model, kita ambil MA model. MA model yang kita belajar tadi. So, to determine your MA model, whether your model is MA or AR model ataupun ARMA model. ARMA model kita tak belajar kan? AR model kita belajar. So for MA model, to determine the order, you kena tengok dia punya, kita gunakan istilah Q, Q significant legs. Kita drawkan ACF function. ACF function yang tadi, bila kita drawkan ACF function, kita plotkan ACF function tadi. Ini sebenarnya sebelum ni katakan anda tidak tahu macam mana equation dia. We do not know the equation. We know only the general function. Y I is equal to mu plus by epsilon I plus by theta 1 epsilon I minus 1 plus by theta 2 epsilon I minus 2 plus by dot plus by theta Q epsilon I minus Q. Kita tak tahu lagi. Kita tak tahu apa function kita guna. Sama ada kita nak berhenti setakat ini saja, MA1 ataupun MA2, MA3. So kita masuk ke data tu ke dalam software whatever. So kita call for ACF function, ACF plot. Dia panggil polygram plot. Polygram. Tak saya lah, tak silap saya. Polygram plot. So you call for ACF function plot, ACF function, autocorrelation function. Then you ambil the lag berapa? Katakan you ambil lag sebanyak 10 lag. So the x-axis here is lags, log lags. 1, 2, 3, 4, up to 10 lags katakan. Ada 10 lags. Tiba-tiba you tengok dia punya row here, di y-axis row hanya ada satu palang. The maximum is 1.0. Selalunya dia less than 0.5 lah. So kadang-kadang ada satu palang. The rest is equal to 0 lah. Semua dia lain semua 0. Sini. Dia tak exactly 0 tapi hampir-hampir 0 pun boleh kira lah. 0. So kalau you jumpa begini, you katakan model MA1. Okay. Kalau you plot lagi, tiba-tiba you jumpa dua palang. So modelnya lah MA2. So disebut MA, kita akan jumpa Q significant logs. Kalau kita nak menentukan model tu MA, makanya kita mesti adalah Q significant logs. Okay. Kalau awak plot, satu lagi lah plot PACF. Benda ni kena significant. This part must be significant. Kemudian awak plot bah, satu lagi saya tak ajar lagi, dia kata PACF, partial auto correlation function. For the partial auto correlation function, PACF, partial auto correlation function, separa partial auto correlation function. Kalau you plot partial auto correlation function, you find that dia panggil geometrically decreasing. Dia akan buat gini. Kita ada lag, kita ada row. Dia palang dia macam ni, banyak palang tetapi dia menurun. Dia panggil geometrically decreasing. Di palang ini menurun. Dia bentuk geometri. Secara menurun secara geometri. Geometrically decreasing. Okay. Nilai. Inilah PACF function. PACF function. So dia ada dua. You plot, yang pertama you plot ACF, you jumpa dua palang. Dan bila you plot PACF, you nampak macam ni. Dia menurun. Makanya kita pilih MA model. Okay. Untuk AR model, padam. AR model ataupun auto regressive model Bila you plot ACF, this one talking about AR model. AR model. When you plot ACF, kita akan jumpa dia punya geometrically decreasing function. So dia begini. 1, 2, 3, 4, 5 dan seterusnya. Dia menurun ini. So plot ACF. Dan PACF, awak akan jumpa significant lag. So contohnya dia ada this PACF. Dia ada 2 palang. Hanya 2 palang. Significant. Significant. Ini row. Significant, makanya kita gunakan this AR2 model. AR2. Berbeza dengan MA model we refer to ACF. ACF kalau ada 2 significant, makanya kita gunakan MA2. Tetapi kita kena check pula PACF. PACF dia menurun secara geometri. That is a MA model. For AR model, ACF-nya mesti geometrically decreasing, while PACF-nya dia ada 2 palang. Kalau 2 palang, AR2. Kalau 1 palang, AR1. Itu cara mengenal pasti AR model dan MA model. Berdasarkan kepada graf. Berdasarkan kepada plot. ACF plot and PACF plot. Faham? Jadi, kalau anda ada kesempatan, kalau anda boleh downloadkan software SPSS, contohnya, you boleh masukkan data, you boleh request for ACF function and PACF function. Jadi kalau awak nak tentukan model dia, awak boleh tengok kalau ACF function dia geometrically decreasing, and PS function kita ada P significant lags, makanya kita gunakan AR model. Tetapi kalau kita plotkan dalam ACF, kita dapat Q significant lags. Pasal MA model kita refer to MAQ kan. Kalau AR model kita katakan ARP. Dia sebut gitulah secara umum. So MA model kalau you jumpa ke Q significant lags, contohnya kalau dekat ACF-nya ada 2 palang je, makanya kita gunakan MA2. Tetapi di PACF dia ada istilah geometrik. Geometrically decreasing. Dan akhir sekali ARMA model yang belum saya ajar, dua-dua kena geometrik. Barulah kita gunakan AR ataupun ARMA model. ARMA model is a combination of auto regression and moving average. That is ARMA. Satu lagi lah SARIMA ataupun ARIMA. ARIMA banyak lagi model-model gitu. So ARMA model is a combination of AR dengan MA. Kalau SARIMA is a seasonal, dia ada masuk seasonal di situ. Jadi banyak model dalam time series dan it's a complicated model. Kita perlu bantuan komputer, software untuk plot dan sebagainya. Kalau you nak gunakan secara manualnya agak sukar. Tetapi kalau nak gunakan secara manual setakat MA1 and MA1 and AR1 masih lagi boleh, ataupun maksimumnya MA2 ataupun AR2. Kalau dah sampai 3, 4, 5 tu kena gunakan software lah. Because of dia punya pengiraan semua dah complicated lah. So hari ini saya telah habiskan mengajar anda MA1 dan MA2, bagaimana nak mengenal pasti dia punya model-model tersebut dan bagaimanakah kita proof formula MA1 tadi. So, dan MA for MA1 function, dia punya row ni mestilah for MA1, row mestilah korelasinya mestilah kecil daripada, kita boleh estimate provided your row, the absolute value of row must be less than 5. Okay. MA1. Okay. Must be less than 0.5. Kalau more than 0.5 dia ada masalah di sekitar model tersebut. Model tersebut disebut sebagai nama lain. So MA1 rho dia mesti less than 0.5. Sebab itu bila kita tengok tadi, rho for MA1 kebanyakannya less than 0.5. Theta tak apa, rho nya mesti less than 0.5. Okay, so saya dah menunjukkan MA1, MA2. I have proved MA1 formula dia, dan juga saya tidak perlu MA2 tapi saya dah upkan formula MA2. Seterusnya saya telah tunjukkan bagaimana nak mengenal pasti model-model MA dan AR berdasarkan ACF dengan PACF function. Tapi PACF function ni saya tak ajar lagi minggu depan saya akan ajar PACF function. PACF function. Tadi saya tunjukkan ACF function saja untuk MA. Moving average. Okay, moving average. Okay. So in other words, moving average atau correlation function is rho. Rho is berkaitan dengan covariance over the standard deviation of X and standard deviation of Y. Covariance of X, Y, konsepnya adalah sama dengan, rho adalah sama dengan konsep correlation. Rho is a covariance of X, Y over standard deviation of X and standard deviation of Y. Tetapi kita untuk function tadi, kita just put a covariance of Y, I and Y, I minus H. And this one is just put a variance of yi. Sebab variance of yi and variance of yi minus 1 is standard variance of yi and variance of I minus 1 benar sama. So rho is a covariance of rho of H is a covariance of yi minus H divided by variance of yi. From here, you can get the autocorrelation function. Because of untuk rho 1 is equal to theta 1 over 1 plus by theta 1 square. Okay, that is rho 1. Kalau MA ni saya MA1. So MA2 kita ada MA2 we have rho 1 and rho 2. Okay, so put the formula there. Kita ada rho 1 and rho 2. Rho 1 and rho 2 is referred to autocorrelation function. Okay. So bagaimana nak estimate tu saya dah tunjukkan tadi, how to prove the formula. Kalau you are given the equation, for example you are given this type of equation, yi is equal to mu, katakan mu is equal to 10 plus by 0.3 epsilon I minus 1 plus by epsilon. So from here you can estimate your rho 1 because of this is the MA1 model. You can estimate your rho 1. Rho 1 is equal to theta 1. This is theta 1. Theta 1 is 0.3 over 1 plus by 0.3 square. This is your theta 1. The rest, theta rho 2, rho 3, up to rho H, rho K, up to rho Q, is equal to 0. Okay. Kalau second model, let's say we have yi is equal to mu, katakan 2 plus by theta 1 is 0.3 epsilon I minus 1 plus by theta 2 is 0.4 epsilon I minus 2 plus by epsilon I. So this is an MA2 model. You can estimate your rho 1 and you can estimate your rho 2. So by definition, rho 1, kalau kita lihat di sini, Okey, kalau kita lihat di sini, rho 1 is equal to theta 1 plus by, so rho 1, for this case, rho 1 is theta 1. So your theta 1 is 0.3 and theta 2 is 0.4. Rho 1 is theta 1 is 0.3 plus by theta 1 is 0.3 multiplied by 0.4, for example, and divide by 1 plus by theta 1 square, 0.3 square plus by 0.4 square. You solve ke sini, you akan dapat rho 1. And rho 2 is theta 2. Theta 2 is 0.4 over 1 plus theta 1 square, 0.3 square, plus by theta 2 is 0.4 square. So from the equation here, from this equation, from the what you call, from the MA2 equation here, you can estimate your autocorrelation function for rho 1 and rho 2. Okay? These are what I have learned just now. And before that, I have proved rho 1 only. Rho 1. Rho 2, for rho MA2, I want to tengok dia punya proving. So it's quite difficult lah to prove. So at least we have proved for MA1. Ada apa soalan? Okey, kalau tak ada soalan, untuk minggu depan, kita akan adakan kelas secara bersemuka. So face to face. So face to face minggu depan, kelas kita normally start pukul 9 9 ke pukul 10? Yang actual class.
10 Doktor.
10.
10 kita kelas kita di blok akademik kan? Kelas kita di blok akademik blok akademik masanya pukul 10. Pasal kita tertunda ada 3 kelas yang kita perlu buat secara bersemuka. Dulu kita ada buat sekali maknanya kita kena habiskan 4 kali. So minggu depan sekali, minggu satu lagi tu minggu depan pada, tak silap saya, pada Khamis adalah 1 bulan 1 bulan Jun minggu depan sekali. 7 hari bulan Jun saya tidak ada di Tanjung Malim, di Seri River. Saya berada di Ipoh. Jadi saya akan berikan kelas secara online ataupun kita tidak ada kelas, tengok depend kalau saya sempat sediakan nota, saya buat kelas secara online, ataupun kalau tidak ada, saya tak sempat buat nota, saya akan bagikan assignment so you can discuss with your friend your assignment untuk preparation for test assignment untuk preparation for test. Kemudian minggu yang seterusnya kita buat lagi face to face. Dan mungkin minggu yang seterusnya, minggu depan kita ada kelas, minggu satu lagi tu saya akan bagi assignment, you discuss, you buat ni untuk preparation for test. Minggu yang seterusnya kita buat test, face to face test, dan seterusnya kita buat revision lah. Untuk time series. So saya terhutang lagi satu lagi assignment. So minggu depan saya akan bagi assignment, dan minggu depan ni is a face to face. Okay?
Boleh Doktor.
So saya rasa itu sajalah untuk pagi ni, dan saya ucapkan terima kasih, dan jumpa lagi pada minggu depan secara face to face pukul 10 pagi di blok akademik di bilik yang hari itulah masa kita jumpa mula-mula. Okay. Assalamualaikum warahmatullahi wabarakatuh. Investing.com. Okay, investing.com. Okay, nampak ni investing.com. Now you go to technical ataupun you go to stocks you go to stock screener contohnya. Stock screener. Stock screener ni bila you go to stock, you go to market, you go to stocks and then you go to stock screener. Apa-apa lah you boleh cubalah stock screener. Contoh saya ambil stock screener di sini. Nampak kan
Nampak doktor?
Okay, contohnya saya ambil satu saham Tesla je. Tesla ni lah, Tesla ni adalah kereta syarikat kereta Tesla, kereta elektrik, kereta elektrik. So dia akan keluar. This is Tesla punya stock market. So monthly, weekly, data weekly, daily. Hari ni tengah turun, sahamnya tengah turun. Dia sahamnya mencecah pada 14 hari bulan 2 2023 mencecah sampai RM214 satu saham. Hari ini telah menjunam turun ke 182. Kemungkinan dia akan naik balik lah. Hari ini tak habis lagi dia akan naik turun. So this is a chart So kalau chart ni, kalau awak nak chart ni dia ada macam-macam chart. Dia ada macam-macam chart, you boleh pilih kat sini you boleh pilih. Dia keluar. Awak boleh pilih technical chart Dia macam-macam chart. Dia macam-macam chart dia ada. You boleh pilih technical chart Saya chart charts. Interactive chart. Ataupun you klik ni. Kat sini dia bagi bar chart Sekarang ni saham ni tengah turun Saham ni tengah turun. Dia tengah turun. Tapi pagi tadi dia naik sekarang ni sekarang dia sekarang ni tak buka lagi Sekarang Tesla dia tak buka lagi. Saham dibuka pada pukul Malangkaran dia buka. Ni dia tak buka lagi. Stok dia tak buka lagi, dia tak open lagi Kalau awak tengok di sini close lagi dia ada indicator di sini. Kalau awak tengok dia close lagi, dia tak dipasarkan lagi. Close Jadi close dia close. Dia masih lagi close So dia masih lagi close, dia buka waktu kita malam sekarang lebih kurang dalam pukul 9 dia akan running. Dia akan running, awak akan lihat chart ni dia berubah. Dia chart turun naik. Jadi kalau you berminat dengan saham boleh dah tengok benda ni. So saya cadangkan awak jangan gunakan formula kita lagi Formula tu tak strong lagi Kalau awak pakai formula tu nanti awak kalah saham ni, jangan marah saya. Saya belum tak habis mengajar lagi So kalau nak mengajar saham ni dia lain pula dia punya cerita dia. So contohnya di sini kalau awak lihat di sini dia punya bar di sini, nampak bar di sini inilah yang level yang paling rendah. Dia menurun di sini dan naik. Ini dia level yang paling rendah. Jadi jika you nak beli saham, you nak tempat yang terbaik nak beli saham ni lah, you tunggu harga tu jatuh kat sini. Jatuh ke 184 mata, 164.51 sebab ini harga terendah. 164.37. Bila harga saham tu jatuh kat sini, awak beli. Sure dia akan naik balik. Sebab ini dah harga terendah. Kita tengok kes kat sini. Dalam kumpulan ni, contohnya dalam kumpulan ni, harga terendahnya lah dalam kumpulan ni, dia naik, lepas dia turun balik kan. Lepas dia naik balik kan. Harga terendahnya ialah dekat sini. Nampak tak harga terendah kat sini? 176.02. Jadi awak biarkan saham tu bergerak dulu. Bila dia mencecah harga 176.02, awak beli kat sini, dia akan naik. Lepas naik ni, awak rasa boleh nak ambil profit, awak profit, lepas tu awak biarkan. dia akan turun balik. Sama juga kat sini. Sama ada you boleh ambil, you boleh beli kat sini ataupun you tunggu lagi sabar, tunggu dia turun sampai ke sini baru beli. Mana dia akan naik balik. Itu lebih kurang trendnya, tapi saya tak nak ajarlah. Jawab main saham dia kau kalau saya menyalahkan saya pula So itu cara dia, antara cara dia macam-macam. Kalau kita nak ambil moving average pun dia boleh keluarkan dan sebagainya. Tapi tak apa, itu that is the graph yang telah dibuat. So apa yang saya nak tunjukkan di sini lah, saya nak pergi kepada data history, data sejarah dia. Sorry. Market stock screener dia, market stock screener. Saya pergi kepada Tesla. Tesla is my favorite stock. Tapi dia Tesla ni stoknya agak mahal. Okay, stock pergi kepada market, pergi kepada stock screener. Saya ambil Tesla dulu lah. Mana Tesla ni? Hilang dah. JP Morgan Tesla. Ataupun awak type Tesla ni. Nasdaq 100 Nasdaq 100 is Tesla ni. Nasdaq 100 is saham-saham teknologi. Tesla di consider. Okay, you pergi historical data. So this is historical data. Bila awak klik historical data, awak akan dapat ni. Nah, macam mana download ni? Sebelum you download ni, you tukar tarikh dia. You tukar kepada Februari. Katakan 2 Februari sampailah hari inilah. So you boleh download ni. So bila kita download data, dia keluar bagi data. So this is data. Dan data ni saya nak you analyze the price saja. High low ni jangan volume jangan kena. Saya nak you analyze the price saja. Dia ambil data ni, you buatlah model-model yang bersesuaian yang saya sudah ni. Okay. The price saja. Okay. Daripada diberi sinilah 24 hari bulan dia bagi daripada bulan 2 2 hari bulan 2 hari bulan 2 sampai 24 bulan 5. Maknanya data ni daripada bawah ke atas Kita balikkanlah. Ini data awal data awal. 2 hari bulan 2. Awak kena reverse ke data ni. Pasal kita punya calculation kita daripada time 1 hingga time yang terkini Awak kena macam mana nak terbalikkan data ni? You copy this one. Ctrl C, dia terbalik data You letak dekat sini. Ctrl B contohnya. You copy, Ctrl C. Then you transpose paste special transpose kalau kita transfer apa jadi? Tak perlu awak carilah macam mana. Tapi data ni terbalik data ni daripada highest ke lowest. Kita nak ke lowest ke highest kan? Jangan silap Data ni daripada terkini hingga yang ke bawah. Kita nak daripada bawah, daripada yang sepatutnya di sini dia terbalik kena inverse kan, dia terbalik So awak carilah macam mana nak terbalikkan. Saya tak dapat cari di sini tapi ada cara dia dalam Excel boleh terbalikkan. Ni boleh kan?
Boleh, Doktor.
So itu terbalikkan data. Sebab data tu daripada terkini dan yang terakhir daripada bulan Mei sampailah bulan Mac. Yang kita nak analisis daripada bulan Mei hingga bulan Mei hingga Februari. Yang kita nak yang di sini kita kena start ke Februari hinggalah bulan Mei. Terbalikkan data tu. Sebab our formula dah terbalik Okay, saya situ sajalah. Untuk ni you boleh
ada lagi nak tanya.
Okey.
Untuk predict tu, kita nak predict sehari ke berapa hari?
Sehari saja, jangan predict jauh.
Sehari je. Lagi satu kan dia ada weakness and strength kan. Kita kena bagi tahu untuk ketiga-tiga method ke macam mana?
Ketiga-tiga method.
Ketiga-tiga method. Bukannya kita cakap tentang Apple. Maksudnya kita cakap tentang method tu.
Bukan Apple. Apple tak nothing to do with Apple, je just data. Method kita.
Oh, so kita cakap tentang method kita. Okay, boleh.
Data dia tak ada weaknesses. Data dia memang real data. Itulah yang bagi. Tapi weaknesses ni lebih kepada kita di method. Method ni dia ada kelemahan dia, ada kelebihan dia.
Lepas tu doktor, perlu masa dekat conclusion perlu ke kita cakap which method lagi better?
Boleh.
Boleh.
Ya. Ada ni.
Okey doktor, tu je.